Okay. So once you're done with an exam, yes, you can go back and you can look at the results of that attempt and you can see which questions you got wrong. And yeah, that feedback should not go away. Let me know if it goes away. I'll try to fix that, but it shouldn't. Tells you, I believe it tells you the right answer, but it tells you where to look in the book.
I was gonna say, I think it tells you what section it's part of.
Yeah, it shows you exactly which section, subsection, basically paragraph to read about that one particular thing. So be sure to go back and read that. And yes, NetAcad does make these questions hard. Oh yeah.
Some of the wording on it was.
Yeah, that's what I'm saying.
Yeah.
Wording too, it's like tricky.
Strange. on
Yes, no, they definitely test your understanding of it in those questions. Certification exam is gonna be no different. Okay. I'm hoping to take this CCNA certification. If we get enough folks into the 160 class to where we can run it. I will try to sign up sooner rather than later so that, you know, looks more promising. I know that A, it's gonna be tough to fit in some of your schedules, and B, since it's an elective, it's not covered by a lot of financial aid. I understand that. But hey, the Cisco certifications are pretty powerful because they're difficult. There's not a whole lot of folks out there who have them. I've heard of CCENPs, which I don't think is quite the top of the pyramid. But those are the folks that get flown around to go fix things. It's like, hey, we need you in South Korea right now. Probably a little bit less of that now with all of the remote work, but I've heard of it.
Just out of curiosity, if we do have to pay for that class out of pocket, how much is it?
So it depends on how many classes you're currently taking. If you're full-time, then it should be free. Should be free. Don't quote me on that because our classes are extra. They're a technical education with lab equipment kind of class, because this stuff ain't cheap. The instructors actually are probably the most expensive thing about our program, to try to find somebody to teach these classes. So that aside, you know. But yeah, if you're full-time, you should get a pretty heavy discount on that. But don't burn yourself out. Don't stress yourself too much, all right? The way our degree program works is classes are only offered in one semester. So if you fail that, you've got to wait a whole year to resume your degree. Not the most ideal thing. So first and foremost, pass your classes, get your degree. Okay. Trunking in commands to be on, yeah. What was the simulation? There's probably a couple different simulations, or at least they change around the IP addresses. But what'd you have to do for that? I forget. I took this. It was a while ago. I kind of took the whole course at once, so it kind of blurred together.
Just trying to find the server.
Trying to find.
I got that one. You have to activate the connection between PC1 and the server.
Mhm.
And then within the switch check the address to see what website is.
So it was quite stressful because my packet tracer is doing the request timeout thing constantly. So I had to go back and refresh it again.
So was it packet tracer that was request timed outing, or was it?
It was the web browser with them.
It was the web browser. Yeah, okay.
Took me like a total of 10 minutes to do that one.
For some reason, from my years of working with NetAcad, it's like they keep two tokens. One for the main login, that's your Cisco ID, because sometimes you get sent to cisco.com.
Mhm.
That's usually only if you create it for the first time or log in for the very first time. It's a Cisco ID password. That is the SSO. Now, single sign-ons, right, like YC, is Canvas uses our SSO to keep you logged in. But Canvas will, that token in your browser cookie expires. It's just the way that NetAcad does it. I swear there can be like two tokens with different expiration dates. And if one of them expires, then you're signed out, or that session's no longer valid, which means you can't commit any more changes to the web page. because you're not authenticated. So the thing there is, so if you're constantly getting timed out, close all your browser tabs, every single browser. Okay, because I think it goes across browsers. And then go back to Netacad on one browser. I mean, really shouldn't have anything else pulled up anyways when you go to take these exams. All right, but better be safe than sorry. So they use loose semantics too. Yeah, but you're gonna find in the industry that there's lots of loose semantics. I actually have a thing for you. It's a Reddit post. I was gonna find out from the internet, how are they pronouncing PAGP? This is a common thing you'll find in IT where it's like, oh, you've read it this way. It's just the reality of being constantly online. We rarely speak to each other, especially in our learning. So we might learn it one way, we say it in our heads one way. So I found this on r/networking. Sounds a lot like deprecated. That means don't use PAGP, okay? It's pronounced lol, learn to LACP, bro. All right, so stuff like that. This person says, I've heard it pronounced PAGP, PAGP. This is how I say it in my head, PAGP. Or you're saying LACP wrong again. So, and then other folks are saying the G is silent, PAP. No, I'm gonna disagree with that. Because there's another authentication protocol. Well, it has to do with authentication called PAP. PAP and CHAP don't. No, that one's taken. Okay. Oh, we have someone who's disagreeing. Enhanced PAGP. Yep. Yep. So fun stuff. Yeah, so there was quite a few of us whose Netacad exams, or sorry, packet tracers decided to become disconnected. That's fine. Just close the exam window. Your progress will be saved. And then the window that's left, just click resume and connect packet tracer again. Okay. Correct me if I'm wrong, but everybody got it to connect on the second shot? Okay. Sure. All right, in Web Live, I'm gonna keep all your faces up there. Can someone talk? Know if the audio is working.
Testing, testing.
Mic check.
Say that again.
Mic check.
The
Okay,
duck flies backwards at night.
so you're just quiet. 1 second. All right, let's try that. Say hello.
Mic check.
Hello, hello.
All right, we'll just turn you all the way up. Okay, we'll go with that.
All good.
All good. So feedback, there was no audio in the very beginning when I turned on the computer, and now it's working. Okay. Let's get started with chapter 5. All right. So chapter 5 is all about STPs. Okay. Let's see. Is this acceptable, Web Live viewers, or I can try to zoom in a little bit more to the screen itself? Yeah,
Go ahead and zoom in more.
okay. And I want to go to the left a little bit.
Perfect.
Yeah, well, I'm trying to. It's not consistent. Oh my gosh. you know what, let's just go with, let's just go with that. All right, and then you guys can, yeah, we'll just go with that. All right, that's not for you, sorry. Okay. All right, so this is actually a pretty short chapter, but what we're gonna talk about is absolutely crucial. STP is always there unless you turn it off. Turning it off would be a very bad idea, okay? What would happen in a multi-layer redundant switch environment? What would happen if we turned off STP on all of the switches? What would that create?
Loops.
Create switching loops. Now, as soon as one person sends a broadcast over an unregulated switching loop, what happens? Sorry? A storm. What is that storm called? Broadcast storm. Yes, it's called a broadcast storm. Broadcast storms are no bueno. They're going to just, it's gonna just exponentially create traffic to the point where your whole network is just bogged down. These switches are working their fastest, their fullest, sweating, drawing lots of power. Yes, Gary, yes. So that's what we're gonna talk about. And STP takes care of that issue for us so that we don't have switching loops. This chapter is pretty text heavy, so I'm gonna ask that you go over it again. Good thing to do would be to have this video opened up in one tab, and then you can read the PowerPoint in another tab and just have me talking about it, pausing the video periodically to read these. Okay. So basically, we're going to be talking about STP. Redundancy is absolutely crucial. You're going to have, any good, solid, scalable network is going to be redundant. And that necessitates your understanding of STP. Because STP in a simple flat network, sure, that's relatively easy to understand. But VLANs complicates everything, okay? You now have many, many, many networks that kind of exist in different forms on top of your physical architecture. Remember, you can have certain VLANs on this part of the network and certain VLANs on this part of the network, and then certain VLANs everywhere. Okay, so STP is gonna look a little bit differently for each and every one of those VLANs, potentially, as we're gonna learn. All right. So if you have redundant networks, you are going to have redundant physical paths. That's just, one equals the other, okay? Individual ports go down. One end of a cable goes bad. You lose a tongue on the end of an Ethernet cable and it just slides out. Eventually, it's going to become disconnected. That is what stopped our VPN server from working for quite a long time. And it took me a while to figure out that it was just one cable. All I needed to do was push it in. You know what I did to make sure that I didn't ever have to push it in again? That would be the right thing to do, replace the cable. I taped it. Okay, because I don't know if you've ever seen a server rack, it's all the way in there. So that was the quick fix. Not best practice, right? But I can't even bring up the hourly excuse, So I have no excuse for that one. But hey, hasn't gone down yet. Oh, I know I didn't replace the cable. The server, the bottom of the server has a level to it, and then the port goes in tongue down. So you cannot, my fingers are not the biggest fingers. I couldn't get my finger underneath there to take the cable out because of the poor orientation of the Ethernet port being upside down, way too close to the bottom edge of the server. So credit cards, okay, let's get out a credit card, fold it a little bit, push that tongue up and just get it out of there somehow. Super micro, that was the problem. Not on the Dell servers. Dell servers are great. The tongue is facing upwards like it should be. All right. All right, Ethernet LANs require a loop-free topology. All right, again, if they don't, there is no mechanism to handle a broadcast storm. Okay, the end devices do not handle broadcast storms. They can handle collisions. But do we need to handle collisions when we're only using switches? Yes or no? I hear you. No. Okay. Only when we're using a hub, which is never going to happen, do we need to worry about collision domains and all of that. But we do need to worry about broadcast domains. That's why, okay, now we're understanding why we need to know broadcast domains. It has to do with STP. All right. So, so far, this should be your understanding of STP. You have a switching loop here, and we just shut down one link. That way, it turns into a tree instead of a honeycomb or something like that. Trees don't have loops. The branch doesn't go back into the trunk. If it does, that's a bad tree. It's like sick, infected, or the wind was blowing on it forever. Not a good reason, not typical, okay? So again, it's a tree because we have one switch and then branches. We don't have any loops. All right. All right, so if this line gets cut, goes down, an end falls out, a contractor said, yeah, I'm not moving these cables, and they cut right through them. Happens. It happens. And then they have to pay for fixing all of that. We just go around. Go to a different switch. That switch has a connection back to the root switch. All right. Path redundancy provides multiple network services by eliminating the possibility of a single point of failure. That's just defining redundancy. When multiple paths exist, it creates a switching loop that can cause a broadcast storm that causes link saturation, high CPU utilization. Basically, your network it's running on empty. Okay, it's barely chugging along. You can create a broadcast storm in Packet Tracer. Just go in there, and I think it's on a port by port basis. You just do no spanning tree, and you do that on enough of the ports, and eventually you send one ping. It has to be a broadcast. Okay, we got to create a broadcast. If it's a unicast and the MAC tables are already populated, you won't create a broadcast storm. The broadcast goes from switch to switch to switch to switch to switch. Okay.
Video on the module.
Oh, they do. Good. Okay. Good. All right. Layer 2 Ethernet does not include a mechanism for recognizing and eliminating them. Yep. So we got that. Layer 3 does TTL. Okay, that TTL reaches 0 and we drop the packet, or whatever router receives it last drops the packet. But we don't do that with Ethernet. It would cause more delay because it does take time to calculate this. Okay, it might seem insignificant, but I mean, we're at the point where milliseconds don't matter, it's microseconds. Okay, we're down to the microsecond, especially when you're dealing with 10 gigabit, 100 gigabit, VLAB type traffic needs to be very fast because the storage is going across the network to compute. All right. Yep, it's going to cause a broadcast storm. As the loop occurs, the MAC address table on a switch will constantly change. This is probably the worst part about it. Your frames are just getting sent erroneously all through the network, and then it has a chance of ending up, in the correct spot. You just better hope that what protocol would take care of a retransmission again? What protocol at what layer would take care of a dropped frame?
ASIC.
Huh?
ASIC?
ASIC? Nope, that's a type of hardware, not ASIC. Huh? DTP? Nope, not dynamic trunking protocol. What? There's only one protocol that is considered connection oriented.
TCP.
TCP. Yes, TCP. It's the only thing, the only trick in the book that we have to take care of any issues. Ethernet is connectionless. IP, it's connectionless. IP doesn't care. So that's why we often say TCP IP, because they go hand in hand. All right. I mean, we could say UDP IP, but we don't, because UDP is also connectionless. It's the TCP aspect that's significant. All right. Man, goes on and on. Broadcast storms, right. Overwhelming the network, causing high CPU usage and all that good stuff, all bad stuff. Yeah, they can disable a network within seconds. Who might want to disable a network within seconds? Hackers. Bad actors, threat actors. Bad guys, yeah. So keep in mind as you learn, what can go wrong and how to prevent it. All right. Another reason you need to go to IPv6 and not drag your feet. IPv6 packets are never forwarded as layer 2 broadcasts. It's very secure. Okay, remember a broadcast is seen by every device in that broadcast domain. So that broadcast domain is the VLAN. The extent to which that VLAN is seen and heard across your switches. Yeah, it uses multicasts, which are, it's gonna reduce the scope in which people or computers receive this information. Remember, a layer 2 broadcast is all, multicasts are some. All, some, one, or none. All right, yeah. So in addition to screwing up the MAC tables, it's also going to screw up the ARP tables on the hosts, on the endpoints. So essentially no one knows where anything is on the network and we can't travel across it. Okay, this is gridlock. If you want to compare it to a real world situation, this is gridlock. But imagine that, instead of cars not moving, they're just going in circles around the blocks. That'd be dangerous. Be worse than gridlock. So the spanning tree protocol uses an algorithm, the spanning tree algorithm. So if you want to look into it, here's some information on the person who developed it. So your long and short is we strategically block certain ports, but which ports? What if we end up accidentally blocking the most efficient path to the default gateway? Then what? Well, we're just causing extra delay that doesn't need to happen. So STP attempts to create the most efficient tree across the network. And usually the trunk of that tree is the exit point, okay, your default gateway, your core firewall router, your core layer 3 switch, whatever it is. So the root bridge is that bridge. Now, the term bridge is synonymous with the term switch. So there's your semantics, it's both. Has to do with hubs. So remember, there was the repeater that connected to bus networks or ring networks, whatever you have. So there was that, and it bridged those two networks. Now a multi-port bridge is just a hub. All right. But then what's the most best awesome multi-port bridge you can possibly have? A layer 2 switch. All right. So yeah, we do have to have a root. That is the trunk that creates the rest of the tree. Block redundant paths. So again, tree, there's only one branch to each part, and then it makes a bigger branch. That's your trunk link, that carries all of your VLANs. All right. A blocked port has the effect of making that link a non-forwarding link between the two switches. Creates a topology where the switch only has a single path to the root bridge. All right. Recalculate in the case of a link failure, right? What if one of these elected non-blocked paths fails? Well, then it has to recalculate the entire tree starting from the root. Yeah. Recalculates, unblocks, so that we find the most efficient path back to the root. All right. Yep. So it's not just when a link goes down that you're going to need to recalculate TCP, or sorry, STP. Anytime you change the topology, really. Right. So how does it operate? These 4 steps, and then we're going to go through these 4 steps in detail. So STA means spanning tree algorithm. STP is spanning tree protocol. Basically the same thing. With the distinction that STA is the math, and then STP is the implementation, the protocol of that algorithm in math. All right. BPDUs, Bridge Protocol Data Units. These are packets, frames that are sent to switches, and they're constantly being sent by these switches. Now, do you think a switch is the only device that could ever possibly send a BPDU? No? What do you think? What else could send a BPDU, Davis?
Not sure.
Kali Linux. Yeah, we can just pretend to be a switch and hijack this process, cause a STP recalculation.
Is that the only one?
I don't even know, but I'm sure it does. I'm sure there's a program you can load up to Kali that's gonna, yes, there are programs out there that will emulate a switch. That could be useful for just troubleshooting. I don't have a switch, but we're gonna configure this later, so let me just test it out now. Right, or if you're penetration testing, you can pen test your own network. Sure. See if you implemented STP and BPDU guard effectively. BPDU guard is the feature that will stop any other switches that are not allowed to connect. All right. So we configure BPDU guard on access ports. Okay, because what kind of device do access ports connect to? Not other switches. That's a trunk port. You got trunk ports and the other one called access ports. Yes. So access ports face the endpoints. Now, should we ever expect a switch to be connected on these access ports? No, we shouldn't. And that's what BPDU guard is all about. So if it detects one of these, blocks it. Now, this is really annoying if you're like me and you're trying to, in the other room, quickly set up 4 computers on the lab benches because we have a class larger than 22. And you connect a pocket switch back to one of these switches, blocks it right away. So I had to get into the switch, find out which port it was connected to through the patch map, and then disable BPDU guard. Well, actually, it was the web GUI, so I just clicked the other radial button, or the radio button. Anyways. Other than detecting the fact that we connected a switch when we shouldn't have, right? These BPDU guards or these BPDUs are used in this election and communication process. All right. So we've got 3 different kinds of ports: root ports, designated ports, alternative ports, and, well, a 4th, blocked ports. Okay, it could be in a blocked state or designated to be a blocked port. All right, bridge IDs, BIDs, it's a value that's in a switch. Every switch has a BID, and they are unique because they're based on the MAC address. Right? But it's more than just the MAC address. It's a priority value, which you set. A MAC address, can't really change that. And the extended system ID. How the extended system ID is derived, I believe, is based on the manufacturer. So in Cisco's special version of STP, who do you think gets the better extended system ID, Juniper or Cisco? Cisco, of course. They're going to give themselves a better priority. And yes, there are different versions of STP, as we're going to see. All right, bridge priority. So this is a value between 0 and 61,440 increments of 4096. Don't ask me why. Has to do with binary. But you might need to do some math. In fact, I know you will, because it's going to be in the exam. It's gonna give you a multiple of 4096. And it's going to ask you how many switch hops away. All right, because the cost increases with every switch hop. And that's how the switches tell how far away they are from the root bridge. And the closer to the root bridge you are, you have a faster connection, so you're going to have a lower bridge priority.
So that can be found out trace.
No, traceroute does not find this information.
It doesn't find hops.
It does find not layer 2 hops, layer 3 hops. Big difference. Your packet could go across 1 layer 3 hop, but go across 80 to 100 switches. Oh yeah, and it's still going to be the same packet, but the frame is the same until it reaches a layer 3 device that strips off the frame to look at the packet. Okay. But as soon as it goes across another layer 3 hop, new frame to get sent across that network because they're separate networks. Yeah, layer 2 and layer 3. There is plenty of jobs just around those 2 things. Just those 2 things. Oh, disgruntled employees. Wait, what was that in response to again? Oh, I don't know. All right, made sense at the time, I guess. All right, so these are the 3 values. Yep. Extended system ID. Yep. And then finally, your MAC address. When 2 switches are configured with the same priority, because this is totally possible, and have the same extended system ID, in other words, they're from the same manufacturer, or in this, the same VLAN, the one with the lower MAC address is the one that will have the overall lower BID. The value, the actual, what we would think of as decimal value, 1 through 10, that matters. When you have 2 devices that are of equal distance from the root bridge, you know, and they have a connection, you'll see what I mean. It matters. It also matters to Windows, by the way. Student came in and we figured out, so my workstation back there has two NICs connected to the same layer 2 VLAN. So they're of equal cost back to the, well, technically they're not. One goes through a pocket switch, so that's probably why. Some pocket switches, by the way, are not STP aware. They don't participate in this bridge priority. They won't increase their bridge priority. They don't send BPDU guards or BPDUs. All another reason to buy managed switches that have the feature set you need. And you need to look at these spreadsheets, the specifications webpage, you know. But yeah, anyways, so I have two NICs. The one with the lower MAC address is the one that handles all the traffic. It just so happens to also be 10 gigabit. The other one's 1 gigabit. So I hope that it depends on the speed, the connection bandwidth first, rather than just arbitrary MAC address value. But anyways, it's the MAC address is often the deciding factor if nothing else is available. All right. What's going on here? So STA designates a single switch as the root. Most of the time, this is somebody says this is the root, and then spanning tree goes from there. Okay. You usually don't leave it up to the switches. I mean, but you know, the default gateway could be over here, but if you make this the root, then this one becomes blocked. Your traffic has to go around when it should be going this way. So if this is your root bridge, put your router right here. It's just what you should do. Okay. All right. So we elect the root bridge. So let's look at this. The bridge IDs are all blank. These two have a higher priority than this one. So right then and there, that's going to become the root bridge. We don't even need to look at the MAC address. All right, all switches in the broadcast domain. Again, why you need to understand the extent of your broadcast domains. You need to know which switches are participating in this. So after a switch boots, it sends BPDU guards every 2 seconds. So this is some of that traffic that is just part of the network, okay? It is overhead that you can't get rid of unless you disable STP. That's not a good idea. If you want redundancy, that's not a good idea. All right, so they contain the BID. So that first part. Right. Switch with the lowest BID will become the root bridge. At first, all switches declare themselves to be the root bridge. But eventually they'll learn about one that has a lower one. Yeah. Sent as broadcasts, everyone's going to see it. All the switches are going to see it. All right. Because the default BID for, unless otherwise configured every switch, it is possible for 2 or more switches to have the same priority. In this scenario where these priorities are the same, the switch with the lowest MAC address will become the root bridge. So, well, they set the priority differently. Oh, well, that's
Switch 2 and switch 3 are they're the same though.
right. Well, all I'm saying is they're contradicting themselves what they're saying over here. This is not the lowest MAC address.
Right.
But so in the event that all of these would be the same, the priorities, which switch would be the root? All the priorities were the same. 2. Yes, because 2 has, yeah, all right. If that A was on the left, one more character to the left, would that be the lowest? Still? No. A higher number. Higher number. Basically, if you want to find out what the lowest hex value is, just like you would decimal, start from the left. Okay? They're all zeros, so that's equal. And just keep going. Remember, F is the highest you can count. What's the value of F in hexadecimal? Anybody? 15, yes, 15. VLAN 1. Can you ever get rid of VLAN 1 on Cisco switches?
No.
Nope. It's always there. So we should see 32,769. All right. So here's your first introduction to the fact that there are two different versions of STP. These are the two big main versions. You've got regular STP and then you've got R STP. And for rapid STP. All right. So STA starts determining the best path. The path information known as the internal route path cost. I know that's a mouthful. You just need to look at this, the cost. Okay, what's the cost from one switch to get to the route? If you go over more switches, the cost increases. So we can see here, the slowest links, no matter how many switch hops you are gonna have the highest costs. Okay. So we can be directly connected with 10 megabit, or we can be, what is that? 1,000 hops, but all 10 gigabit, and it would be equal. And yeah, absolutely. I would still go the 10 gigabit route, even though it's gonna be maybe a second late. No, not even. About every switch adds, every switch adds less than a millisecond, so 1,000 switches would be half a second, maybe. It's not that much, but that matters with phone calls. Live video conferencing, half a second matter. Gaming, okay, absolutely matters.
Voice VLAN is priority, right?
Yeah.
Voice VLAN always has a priority over all other traffic, yes. Yep, and that's why we create a special voice VLAN. Okay, so when a switch does receive a BPDU, it adds the ingress port cost. So this is on a port by port basis here. What's going to cost more? Adds that, and whichever port this BPDU is received on, again, it's broadcasted, so it's going to be received on all ports that are connected. Whichever one it shows up on that is the fastest, that's probably going to be the root port. Port cost is configurable. So not only can we override this whole thing and say this is going to be my root switch, we can determine the path if we know best. All right, as the administrator. All right, step 2. So again, that was step 1, determining the root bridge. Now we need to elect the root ports. Okay, so in this example, S1 is the root bridge. every non-root switch will select one root port. One root port. Because no matter where you are on a tree, any leaf on a tree has one connection down to the ground. That's it. All right. Yep, and that one's gonna have the lowest cost. So whatever is both higher in bandwidth, but also lower in terms of hops away from it. Internal root path is equal to the sum, so we're adding all these paths together, of all the port costs along the path. Okay, so what's quicker? A or B? A. A is definitely quicker. Regardless, well, I mean, you know, if these are 10 gigabit, and to be just extreme, if this was 10 megabit, that would be the faster way to go. But we're not using 10 megabit anymore whatsoever anywhere. It's like hub level stuff. All right. So let's look at how these costs are actually derived. So each hop is worth 19 points here. But since we're doing 2 hops here, we multiply that by 2. So path 1 wins. This is part of what the switches do when they boot. All right, elect designated ports. So designated ports are what's on the other side of the root port, okay? Every switch has how many root ports? One, just one. It can't have 2. If it's 2, then that traffic is getting, you know, especially if it's a broadcast, broadcasted that way, broadcasted that way, broadcasted back. That's a loop.
So only egress.
Yes, only, well, it input, you know, in or out, you're gonna have one root port.
Okay, just
The other side of that root port is always a designated port. Step 3 and 4, I implore you to read over these again, okay? Step 3 and 4 are probably the hardest to understand. You know, without actually doing it, step 1 and 2 are fairly simple. We just elect a root bridge with the lowest value, and then they have an election to determine their own values. All right, but every segment between 2 switches will have one designated port. And that is an absolute truth. Don't worry, we're gonna fill in this blank. You're probably wondering why, what the heck is this? I see root port, or yeah, root port designated. Root port designated. Is the root bridge gonna have any root ports? No, it won't. It is the root.
No, never mind. I think I'm tracking now.
Okay. Yeah. So every port on a root port is going to be designated. All right, but let's read through this. Designated port the designated port is a port on the segment that has the internal root path cost to the root bridge. In other words, the designated port has the best path to receive traffic and then send it on to the root bridge. Okay. So, you know, if you're the switch, what is that going to be for you? It's going to be every other port besides FA01. Every other port. All right. What is not a root port or designated port becomes alternate or blocked, and that comes into play in the next step. That's where we're gonna fill in that blank. Yep. So if one end is root, the other end is designated, won't be anything else. And then there's this. So designated ports. So in other words, should I receive BPDUs on designated ports? Just start receiving new BPDUs that I've never seen before? Should I? No, I shouldn't. All right, unless that was by design, and then we're gonna do an SCP recalculation. Okay, but that's at which point BPDU guard will stop. Okay, if I swap this out for a switch, because this is a designated port, if I configure that with BPDU guard, it's gonna stop it. It's gonna shut it down. Actually, yeah, it'll shut it down. Yes,
So are the root ports the ones that are only directly connected to the root bridge there? Since we
they don't have to be directly connected, no. So if I had a switch down here, then according to pretend PC2 is a switch, that would be the root port. And then that would be designated as well. Yeah, I know. I wish they would give, I wish they would replace one of these PCs with a switch, because 2 endpoints, yeah, we get it. All right, step 4, elect alternate ports. All right. If a port is not a root port or becomes a designated port, then it's going to be the only thing that's left, alternate or backup. Okay, or blocked. You could say 3 things there. But the technical term here is going to be alternate port. So get that in your head. All right. So the S spanning tree algorithm has configured port F02 on switch 3, F02 switch 3 as the alternate role, port 02 on S3 is still in the blocking state. It's not going to work. No frames will be sent or received across that link. But all of the other, all of the other ports are still forwarding. All right. So now we no longer have a loop because trunk 2 has been turned off. Okay. So a helpful way to think about your alternate port is that if we lose our root port, that now becomes our root port. Okay. That's still designated. Now we're going this way. If, for instance, trunk 3 goes down.
Wait. If the alternate port is now blocked off, what's the point of having that designated port, right?
That's from S2's perspective.
Okay, gotcha.
I know, it's a little tricky, but it's a switch by switch perspective. Yeah, you gotta think in terms of that switch's reaction.
Switch 2 is, it's still ready to receive.
Sure.
Switch 3 has it shut off for now.
Switch 3 is the one that's blocking it.
Okay,
Switch 2 is not blocking that port.
gotcha.
Yeah. So switch 2 is listening, but it's listening to nothing. It's ready to go when this fails. Okay, it's ready to go. All right.
That topology can be added on, like say if I needed a 4th switch, I would just plug it in where I needed it.
If that was if that port was not configured with BPDU guard. So So that's like what I experienced in the other room, you know? We have a port that goes to the wall, I connected a switch to it, so now I have a trunk, essentially. And that switch was not expecting to be configured to another switch or connected to another switch. So it blocked it.
Right.
Right, so if that's not on, then yeah, totally, you could connect the switch here. That's not gonna change the topology, if you're just adding a stub switch. But remember, redundancy is the name of the game. So if I have a switch here and I have a link here and a link there, this is gonna be turned off, that link, because that's obviously the quickest route to the root bridge, directly connected. Okay. Now, things get interesting when you're equidistant. So if I put a switch here and then connect to these two, all right, what happens then? Lower MAC address wins. Well, it's all a part of that, it's all a part of your extended BID, the value of all three of those. That ultimately determines which port. So I actually did look it up. When you have, okay, so I was thinking to myself, why was this one elected to the alternate port and not the other way around? They are equidistant to the root. So first, it's so if the switch has two paths that are equal distance, it will choose. So I'm not talking about this topology right now. Pretend that F2 just goes right to the root bridge. It will choose the lower number to turn on. That one wins. Between these two guys, it's based on the MAC address, ultimately. Okay. And remember, they have each other's MAC addresses because they exchanged. What did they exchange? What data unit?
PDU.
PDU, yes. The bridge protocol data unit. All right. Yep. So it considers all of this. So yeah, that MAC address comes into play up there. Okay. So here we go. Here's a square instead of a triangle. Lowest sender BID. So this topology has 4 switches, S1 as the root bridge. Okay. Port F1 on switch 3. We're here. And port F3 on switch 4. Yep, these are root ports. Okay. So what do we do right here? For this guy. This doesn't involve any other switch. It's just a decision that S2 needs to make. So it made this decision as the root port because of the lower port ID. Yes.
So I forget, when it's like blocked, does that mean it's listening only or like nothing happens?
It's not gonna send, and it's not gonna forward anything.
Is it still like,
Is it still listening? That's a good
still
question.
receiving and stuff?
That's a good question. I want to say no, but probably not. I don't know. So the BPDUs are sent every 2 seconds. Well,
It still receives the bit, 2 bits. It comes in,
the 2 bits.
PPU still receives those.
Alright, yeah, so I'm gonna go back to this topology, right? So is S2 sending BPDUs out of F01? I believe so. And it's still. Yeah, S2 doesn't care about S3. It just cares about the root. As long as S2 can communicate to the root, it's happy. Alright, so. S2 might not. It's beyond the scope of this course. Okay. You won't need to know that much detail for the purposes of this course.
But regardless of whether or not it is, it's immaterial because it's able to.
It'll figure it out. If the
Yes,
link goes
that's
down,
one. Yeah,
it'll work. All right, so the bridge IDs of S3 and 4 will be used to break the tie. Okay, so it doesn't actually come down to, I think, yeah, that's the last resort. That's the last thing it will depend on. So the bridge IDs. The sender's BID. Right, because S2 is gonna be the last one to receive these BIDs after the root bridge election, so they get sent out this way and that way, and then they get sent this way last. So S2 will receive last. So they're telling us S3 with this BID, and then S4 with this BID. So it chooses S4. Makes sense?
mostly.
Mostly. All right. You know what I found myself referencing constantly was how these three values are related. Okay. So remember, your extended ID is added, the value of the VLAN is added to the priority. That's why we saw 32,769 instead of 68. 68 is an increment of 4096. But we have to add the default VLAN here. And then finally the MAC address. So let's go down here, back to our here. The next chapter is shorter, by the way. It's shorter. So don't worry too much. So yep. 69, 69, 69. And then it comes down to that MAC address. 1111 is lower than, what's lower? 5 or A?
Right, file.
5, yes, 5. A is a decimal value of what? 10. Yep. 1 through 9, A, B, C, D, E, F. All right, lowest sender port priority. Topology has 2 switches that are connected with 2 equal cost paths. Right, which is very similar to what you guys are going to do with Ether channel. That's why these 2 chapters are taught side by side, because in order to do Ether channel correctly, you really do need to know STP, the depths of STP, at least to this level. Because both ports are connected to the same senders, S1, the first step is a tie. Yep. Same speed, equal cost path to S1. Next is the port priority. The default port priority is 128 on both, so that's a tie. However, if either port on S1 was configured with a lower port priority, so again, you can override this, what's going on here. on a per port basis, okay, so one or the other. Yeah. So which one? All else equal, which one is going to be the root port? Right. S1 is the root bridge. Last tiebreaker is the lowest sender's port ID. So because the port ID of the sender is 1, there we go. So it's the sender, okay? The port number of the sender to that last switch. All right. So let's go back to our triangle topology here and let's think about, well, I mean, the port numbers are the same. So this was determined not on the port number, which one's alternate. It was based on the MAC address. But this is just a different situation because we're looking at two equal links versus two equal paths. So not actually the most relevant comparison right there. All right. Convergence requires 3 timers. Hello timers. The hello is an interval between the BPDUs. The default is 2 seconds. That can be modified. For delay, time spent in listening and learning state. We haven't quite gotten to the listening and learning states, have we? I don't think so. Okay, well, there's 4, I believe. We'll get there. We'll get there. But so if you have a core switch and you need it to start forwarding things immediately because it's the root, okay? Every other switch depends on that root getting its, crap together real quick so that we can converge the entire STP algorithm quicker. Yeah. So this is actually, okay, this implies that yes, a blocked port's still listening. No, that does not. That does not imply that. I need to find out. All right. Well, here they are.
If you cranked all those timers down to the smallest number, would it start causing issues or?
Oh, yeah, I can imagine. Right, yes, because I mean, these timers should be the consistent across the board.
So it's like the recommended time is what the default is.
Yeah, you really, when it comes to STP and in changing these values, whatever these values are, you usually do it to 1 for a good reason. To make something come up quicker or first or sooner that causes everything else to fall in line in a certain way that you expect. I can't even think about what might happen if you change all of these in different ways. So, all right. The spanning tree is determined through the information learned by the exchange of BPDUs. If a switch port transitions directly from the blocking state to a forwarding state, so from here to here, without the information of the full topology, it can temporarily create a loop. So I think that answers your question. It can temporarily create a route. All right, 4 of which are operational states shown in the figure, and the disabled state is considered non-operational. Okay. All right, so if we are blocking, we're not receiving any BPDUs. So we move into this state if no BPDUs are received for 20 seconds, and then we start to listen. In blocking state until STP determines if port is root or designated port. That's if the link comes up. Yeah. So if you add a switch to the network, you're gonna be in this path. The link comes up. Switches figure out what's going on, which side is closest to the root. Listening, learning, finally forwarding.
This is like happening in the background. You don't actually have anything to do with this unless there's a problem with one of these.
Yeah. This is the type of information you're gonna forget about. And then look it up on cisco.com. Someone's gonna have a screenshot of this, be like, I think this is your problem. Look into your delays here. And I'm not mistaken, if you do change these delays, I am pretty sure it shows up in your running config. So that's why it's important to look at a running config and have a good idea of what's going on. What things have you done abnormally? That's usually the first troubleshooting question. Okay, where are we differing? All right. We need a break, don't we? We all taken our breaks by now. Well, it is 7:30, so let's get going. I'm just gonna keep going. All right, summarizes the operational details of each port state. So if we are in blocking, okay, we're only receiving BPDUs, we're not updating our MAC address table, and we're not forwarding frames. Yeah, this just tells you what goes on, what does and doesn't happen at each state. Okay. Listening, learning, forwarding, and disabled. So the only time it's never not, so the only time it's ever not receiving is when it's disabled. Remember, it only ever gets into the disabled state when you do it, or when something causes it to happen, like port security, as we're gonna learn. Port security can cause a port to become disabled. So in every other state, we're gonna be receiving. So yes, the alternate port, or the blocked port is gonna be listening.
Okay.
All right, now the second part of that question is the other side. Is it still sending BPDUs? Yes. Based on what we've been shown so far, yes. Per VLAN STP. So if you thought that was complicated, do it for every single VLAN. All right, it doesn't have to be this complicated as we're gonna see, but per VLAN spanning tree, PVST, there is a root bridge elected for each spanning tree instance, per VLAN. So this does make it possible to have different root bridges. Absolutely. So this last sentence describes it pretty well. If everything is in one VLAN, then you only have one spanning tree instance. Okay. How many VLANs should I want with PVST if I want the best switch performance? fastest switch forwarding? How many VLANs?
Two.
One. One. Every VLAN I add increases the amount of STA calculation that every switch has to do. So all I'm saying is this is not scalable. All right. Many professionals generically use STP to refer to the various implementations. This is absolutely true. So we've got RSTP, we've got MSTP, we just saw PVST. Cisco has the new PVST plus. That's what you should be looking for. That means you're on the latest and greatest of STP. This is another slide that you're going to want to read again. It is slide 40. Slide 40. All right. So you're also gonna be asked a question, the IEEE 802.1D. The D is the original. Okay. And no bueno, bad. The original implementation is described and specified in the D 2004. All right. The primary focus here will be on the standard, will be on the current standard and Cisco proprietary implementations of STP and RSTP. All right. So switches must be explicitly configured for rapid RSTP in order to use RSTP. So either you're using what's default on all of your switches, or you're going to configure all of your switches to do something slightly different. Okay, this is oftentimes why when an organization refreshes, they upgrade their equipment, they upgrade everything all at once. It's expensive. Okay. But it's going to be by far the easiest thing to implement and to keep consistent, right? Long term. So here's your description of all of these. You don't need to know all of them. I would refer to this when you're questioning, oh, what was that one? What was that specific one? But a few of these are going to show up on the exam. Do you have a question?
No, not anymore.
So by all means, reference this when you need it. I'll go ahead and throw it in the Discord. Okay, we're gonna move on. I'm not gonna stare at that too long. I stared at it for a long time when I was going through this first. All right, so RSTP supersedes while retaining backwards compatibility, right? STP terminology is the same. Most parameters are left unchanged. Users that are familiar with the original STP can easily configure RSTP. So that's a connection that you're going to want to make. RSTP is similar to regular STP. Okay, similar, not the same. So instead of doing a strike through, let's just do a wiggly. I don't know if that's at all syntactical. Yeah, and as you can imagine, RSTP is just faster STP. All right, rapid PBST plus, so just everything. Everything. Is the Cisco implementation of RSTP on a per VLAN basis with rapid PBST plus. An independent instance of RSTP runs for each VLAN. And on equipment you buy today, this is gonna be your reality. So this is very important. This is a very important note. It's more important than all of that, in my opinion. If you're gonna be headed towards Cisco gear. It's the pirate version. No. Cisco's not a pro pirate corporation. All right, so there are only 3 port states in Rapid. That's corresponded to 3 possible operational states. Oh, I see what you mean. RSTP. I gotcha. That's confusing because there's the PBST plus, the pirate and R. Nah, no. Let's not go there. All right. You can take a look at this in a later time. Just realize that RSTP guys combines a lot of those things. And then here's your different port roles. All right. Okay, so alternate port has an alternate path to the bridge. A backup port is a backup to a shared medium, such as a hub. So let's see, yeah, we have a hub here. We definitely don't want to enable that. It's a hub. It's gonna cause a loop right away immediately. So yeah, this terminology makes more sense to me, at least. Backup rather than an alternative, right? Because from, well,
Alternate seems like it would imply that it could go either way.
and I'm trying to make sense of that. Yeah, I'm trying to make sense of it. It would make more sense in a square topology, I guess. The word alternate. Yeah, the word backup makes sense when there's only 2 possibilities, but. Yeah, look, you can have multiple alternate ports. All that would eventually lead back up to the root bridge.
In the earlier slides, when it was saying alternate, is that before this got introduced to the RSTP?
Yes, actually, technically. Backup alternate. So let's go back there. We're almost done with this one. Oh, where did it say that? Right here. Alternate or backup. Okay. So without diving deep into the words and the curriculum of it, this is alternate because we're dealing with switches and not a hub. And hub terminology was used because we've got a hub here. But, you know, functionally, they're doing the same thing. Okay. Okay. Port fast in BPDU guard. All right. So when a device is connected to a switch port, or when a switch powers up, the switch port goes through the listening and learning states. Each port each time waiting for the forward delay timer to expire. This is 15 seconds each state for a total of 30 seconds. This can present a problem for DHCP, right? We don't want to wait 30 whole seconds to get our IP address, but we got to take care of layer 2 first in order to send that broadcast and get a response from the DHCP server. Okay, so port fast is something that we can do on top of, regardless if it's STP or RSTP. Port fast is something else. Okay. Transitions from blocking to forward immediately, avoiding the 30-second delay. So we should do this on access ports, endpoint facing, or in other words, edge ports. Edge ports. But if you do this on another switch, you could risk creating spanning tree loops. If at the very minimum, a temporary loop. Okay, because port fast is going to skip those states. All right. Yep, so this feature, BPDU guard, when enabled, it immediately puts the switch in error disabled. That means that you need to put it back to no shut. But if you don't do anything else, there's still a switch connected to the other side. It's going to shut down immediately. It's going to go up, down. Okay, as soon as it sees that BPDU. So you got to disconnect it and then manually put it back in, back into service. All right, alternatives to STP. Last slide here. Over the years, organizations required greater resiliency for the LAN. Went from a few interconnected devices to sophisticated hierarchical networks. Distribution in core layers. Okay, distribution is closer to the endpoints, and then core is just handling all that traffic, layer 2 and 3. Depending on the implementation, layer 2 may include not only the access layer, but as even the distribution or core layers, right? Up to hundreds of switches, thousands of VLANs. We need scalability, okay? So regular old RSTP is probably not going to be the best thing. So STP is adapted with RSTP and MSTP. So again, if you want to, what the heck was MSTP? Go back to that chart. Go back to that chart. All right. Spanning tree. It's an automatic thing. Okay, so are automatic things going to be the best, most efficient? Not usually. Okay, but it saves a lot of time. Okay, layer 2 needs to get up and running right away so that the endpoint users can hopefully get back to the internet. Layer 3, we don't take any time off whatsoever. We have redundant paths connected and ready to go. So if one becomes not available, we just immediately start directing traffic another way. Okay, it's got to go somewhere.
So would it be accurate to say that it's better to do something automatic, something like STP, and then tweak it from there, or just do manually right off the bat?
Well, I'm talking about two different layers here. STP occurs at layer 2. And then what I'm talking about is highly configured, ready to just take, switch. Imagine you have a hose. You got to send that water somewhere. Okay, so when it comes to routing, you got to have an alternate way to go. You got to have a pool, a reservoir, if you will, ready to accept that traffic. Layer 2 is, if you don't have layer 2, you have nothing. So it needs to be automatic. It needs to happen when the power cycles in a building. No administrative fingers need to touch a keyboard in order to get layer 2 up and running again.
Sorry, maybe I mean, just when you're starting out, when you're just building, like say the topography and everything, is it better to let everything take its route and try and do these things automatically and then tweak it from there?
Yeah, because you might not know what the best way for things to look is, until you get a feel for how the network's behaving. Yeah. And expansion, you should always set yourself up for expansion. All right, don't ever put yourself in a corner, so to speak. Okay. So go ahead and take a break if you want. I'm just gonna go ahead and power through chapter 6. You're encouraged to stay and stick around, but it is 8 o'clock, so if you wanna go home, go home. I will be staying and going through this chapter 6.
So chapter 6 be up by tomorrow.
Yeah, both of these videos will hopefully, if I remember, before noon. Both of them will be posted. But that's the video.